Hello. Hello students. Okay. Yeah. Okay, students. Good morning to all. Yeah. Yeah. Students, can you hear me? Yes. Okay. Today's topic is hmm, today's topic is ellipse. Already in the last class we have learned about parabola, right? So in today's class we are going to learn about ellipse, right? So here already in the last class we have discussed about what are conic sections and what are the second degree general equations. That all already we have discussed in the last class. Once again we can go to that. Okay, once again we can go to that. And here topic overview and weightage, then what to expect in the session, in this session. So here the topic overview. So we are going to learn the basics of the basic information about the ellipse. So here reason is there why to discuss only the basic information. Here the basic information in ellipse, from the basic information only we can get the questions. In JEE Mains examination we can get the questions from the basic uh, yes, but the basic definitions and the basic terms with the basic, from the basic terminology only we can get the questions in a JEE Mains examination, right? And what to expect in this session. Yeah, so we can get an idea of ellipse. What is ellipse? What is the standard form of the ellipse? And what different terms we can use here. What is the center? What is the focus? That all we can expect from the session. Right. If we come to the Spark Academy, what you are seeing on the screen, that is a Spark Academy app. Okay, don't waste your time. Download the app as early as possible and continue the classes with the Spark Academy. Right? Yeah. So about this app, already Spark Academy ranked by 1, ranked its rank is 1 in the society. The students and the faculty ranked the Spark Academy as a number 1 institution. So don't waste your time. If you want to prepare for JEE Mains examination, download the Spark Academy app and continue the classes. Right. And what they can provide here. So here you see study material. Here they have given particularly the study material and free test. And next, in study material, what kind of study materials they can provide? They can provide free handwritten notes and free study materials and previous year questions and free mock test. Right? We can expect this all from study material. And every week they can conduct the free test. Am I clear? Every week they can conduct the free test. Next, yeah, what is there on the screen? This is the definition of a conic, right? The general idea about the conic sections can be, already we have discussed in the last class, but let us give a quick review once, because ellipse also one of the conic sections can be generated by intersecting a plane with a cone. A cone has two identically shaped parts called naps. One nap is what most people mean by cone and has the shape of a party hat. Okay. Because here we have to discuss once again about the cone, because the new students also can listen the class today. That is the reason once again we can go through this conic. So conic sections can be generated by intersecting a plane. You know this already, intersecting a plane with a cone. So cone is a solid figure, cone is a solid here. Then that solid is cut or intersect by a plane, a smooth plane. And then we can get the different shapes of conics. So we can name the different shapes of conic based upon their shape. Okay. And here about cone and conic sections. Cone already we know from our childhood, we are learning about the cone. Here two cones are connected each other to get a conic section, and each cone, here they are calling each cone as an nappy, and here each conic is determined by the angle of the plane makes with the axis of the cone. So here just now I have told different conics we can form here. The conics can be named by the angle the plane makes with the axis of the cone. Once we can look into that how it is, you can see here generally we can call it as a cone. No, the one of the part is called as a cone from our childhood. Here we have connected two cones together, then that are called as a naps are connected to each other, then conic section can form. Right, now conic can form. Now these conic sections are generated by the intersection of a plane with a cone. So we are intersecting a cone with a plane here. If the plane is parallel to the axis, of revolution, what is the axis of revolution here? Y axis. What is the axis of revolution here? That is y axis. So if the plane is parallel to y axis, where it is there in the on the screen here, here we have, see here, in this case the plane is parallel to y axis. So what do we get here? We are getting hyperbola. Next, then the conic section is a hyperbola if the plane is parallel to the generating line. So what is a generating line here? If the plane is parallel to the generating line, the conic section is a parabola. So here we can call this line. This line is there, no? We can call this line as a generating line. Our plane is parallel to this generating line. If the plane is parallel to this generating line, what kind of conic section we are getting here? The conic section what we are getting here, it is a parabola. Clear? Next, if the plane perpendicular to the axis of revolution, already I have told you what is the axis of revolution. Axis of revolution is y axis. Axis of revolution is y-axis. So now the plane is perpendicular to the axis of revolution. Then what do we get? We can get a circle. This one. Then the conic section is a circle. If the plane intersects one nappy at an angle to the axis other than 90 degrees. Look into this clearly. If the plane intersects one nappy, at an angle to the axis other than 90 degrees, that means it is not parallel to the y-axis and it is not parallel to the x-axis. Right? Y-axis means what here? Here y-axis is nothing but axis of revolution, and x-axis, that is perpendicular to the axis of revolution. So the two cases are not there. The two cases are not there means it is not the circle and it is not the hyperbola. Then what it is? It is an ellipse. Okay, ellipse can form. That is our today's topic. Ellipse is our today's topic. Then the conic section is an ellipse. So today we are going to discuss about this ellipse. In the last class already we have discussed about a parabola, right? So the definition of the conic. What is the definition of the conic? The locus of a point which is moving in a plane such that the ratio of its distance from a fixed point and the fixed line is always constant is called eccentricity. So what they are saying here, locus of a point. So here it is a moving point, sir. Let us take the moving point. That could be a p of x comma y or x1 comma y1, right? The ratio of its distance from a fixed point. So we can take the fixed point is s. This is some s. Okay. Here we are calling this s as a focus. Okay, this distance ps. And the fixed line, directrix. Here somewhere we have a fixed line. This is the fixed line, right? We can call this fixed line as a directrix. Then the perpendicular distance. This is the perpendicular distance, right? So here we can take it as m. And the fixed line directrix is always constant. So ps over pm. ps over pm. This is always constant. This ratio is always constant. What do we call this ratio? This ratio is called as eccentricity. We can call this ratio as a eccentricity. So we can denote it with the small e. So small e is equals to ps over pm. Small e is equals to ps over pm. Already in the last class we have discussed, in case of parabola, this e should be 1. In case of parabola, this e should be 1. So if e is equals to 1, what do we get? Then we can get a parabola. The conic section is parabola. If e is less than 1, then what do we get? Then we can get an ellipse. So our today's topic is this, e less than 1. If e is less than 1, then what we are going to get? We can get an ellipse, right? Next, general form of second degree equation. Already I have told you, in the last class, general form of second degree equation. What is the general form of second degree equation? ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0. So here what do we calculate? First we can calculate delta. What is delta here? abc plus 2fgh minus af square minus bg square minus ch square. So this could not be 0. That is first point. This delta could not be 0. And what is the second point? h square should be less than ab. H square should be less than AB. Then what do we get? Then we can get an ellipse. In the last class, what we have discussed? In the last class, we have discussed that delta not equal to 0 and H square is equals to AB. Delta not equal to 0 and H square is equals to AB. In that case, we can get parabola. This is our last class. right? And this delta can also be determined with the help of the det form. We can use this det form also, no, to get this. If we simplify that det, then only we can get this abc plus 2fgh minus af square, okay, now minus bg square minus ch square, right? Am I clear to you? Okay. Then the next one is the main concept. All right, let us see what is the standard equation of the ellipse. Let us look into what is the standard equation of the ellipse. Standard equation of the ellipse. What is the standard equation of the ellipse? The standard equation of the ellipse is x square over a square plus y square over b square equal to 1. X square over y square plus x square over a square plus y square over b square is equals to 1 is called standard equation of the, what do we call it? We can call it as standard equation of the ellipse, right? Now let us see what are the different terms included in this ellipse. Means we can trace this ellipse, tracing of ellipse, tracing of an ellipse, right? So what do we mean by ellipse? Generally circle means what? X square plus y square is equals to a square. In that case, what do we do, sir? The center is 0 comma 0, right, and the radius is a. Here what is the difference between circle and this ellipse? We are dragging the circle, like this, we are dragging the circle, then we can get ellipse. Right, here I can draw it. Okay, now this is called, this is the shape of the, what do we say, this is the shape of the ellipse, right? Now in this ellipse, this x-axis, what do we call this x-axis? This x-axis is called as, major axis. What do we call this? Major axis. And what do we call this y-axis? Minor axis. And we can get doubt, how do we know this y-axis only the minor axis, and how do we know this x-axis only the major axis? That is depends upon this value, sir. Relation between a and b. X square over a square plus y square over b square is equals to 1 when a is greater than b. When a is greater than b, then we can call the x-axis as a major axis and y-axis as a, x-axis as a major axis and y-axis as a minor axis, right? And here what is the, vertex? What is the vertex here? This is the vertex. Okay, the vertex is v0 comma 0. Am I clear? The vertex is v0 comma 0. Next, here I can write here what is the vertex here. The vertex is 0 comma 0. Next, in case of parabola, we have only one focus, but here in ellipse it has two focus. So this is one focus and here one focus is there. Then what are the coordinates of that focus? This focus is AE comma 0 and this focus is minus AE comma 0. Okay, this is S and it is S dash. One is S and the other is S dash. Okay, now so focus means here particularly foci. So what are the foci here? S and S dash. What are the coordinates? Plus or minus AE comma 0. Right, and next equations of directrix. Here also we can get two directrix. Then this is one directrix. In case of parabola we have only one directrix, but now in case of ellipse we have two directrix. This is the second directrix, right? First directrix and second directrix. What is the equations of the directrix? So here equation of this directrix is x is equals to a over e, and the equation of this second directrix is x is equals to minus a over e. Am I clear? Equation of first directrix is x is equals to a over e, and the equation of second directrix is x is equals to minus a over e. Clear? Right. Next, let us look into the focus already there, no? And then the remaining things the same as the parabola, sir. What do we call this? This is called as a chord. What do we call it? It is a chord of the parabola, chord of the ellipse. And if this chord is perpendicular, which is perpendicular to the axis, which is perpendicular to the major axis, then what do we call that? We can call that double ordinate. What do we call it? We can call it as a double ordinate, right? If this double ordinate is passing through the focus, if this double ordinate is passing through the focus, then what do we call it? We can call it as lattice rectum. What do we call it? We can call it as lattice rectum. If it is a lattice rectum, what is the question here? What are the end points of the lattice rectum? What are the end points of the lattice rectum? So what are the end points of the lattice rectum? As it is passing through AE comma 0, x coordinate is same. What is that x coordinate? AE. X coordinate is same. So you can substitute x coordinate in this x square over a square plus y square over b square is equals to 1. So what do you get? X square is nothing but a square e square divided by a square plus y square by b square, which is equals to 1. Here a square and a square gets cancelled. Then send e square that side. Yes or no? Then we can get y square is equals to b square times 1 minus e square. B square times 1 minus e square. Then what is y? Then what is y coordinate? Yeah, x square by, yeah, we have substituted here in place of x ae, we have substituted then e square divided by a square we got, and we are sending that y square is equal, we are sending that e square to the other side. Then what we are getting? 1 minus e square we are getting. So here y square is equals to b square times 1 minus e square we are getting. But what is this? What is this 1 minus e square? 1 minus e square is nothing but b square over a. 1 minus e square is nothing but yes, 1 minus e square is nothing but b square over a. So finally what we are getting, sir? We are getting y is equals to, b over a, or b square over a. Yeah, y is equals to b square over a. So here ae comma b square divided by a. This is one end. The other end will be the other end will be like mine here x is positive, same AE comma negative b square over a, AE comma negative b square over a. So similarly, if we see the other side, here also we can get one more. Yes or no? Here also we can get one more. What is that? Lattice rectum. For this lattice rectum, what are the coordinates? For this lattice rectum, the coordinates are negative. No, this side x is negative. So negative AE comma b square over a, and here what do we get? Negative AE comma negative b square over a. Right? They are the ends of the lattice rectum. Clear? Ends of the lattice rectum also we got, students. Then if we got the ends of the lattice rectum, then what is the next pointer? What is the distance? What is the distance between the ends of the lattice rectum? What is the distance between the ends of the lattice rectum? That means what? The length of the lattice rectum. Next point is, what is the length of the lattice rectum? Yeah, tell me, what is the length of the lattice rectum? What do we get? Length of the lattice rectum. So if you calculate the distance between the 2 points AE comma b square over a and AE comma minus b square over a, AE and AE gets cancelled, 2b square over a whole square. So what it is? 2b square over a na? Length of the lattice rectum is 2b square over a. Am I correct? Length of the lattice rectum is equals to 2b square over a. Yes or no, students? Length of the lattice rectum. Where do I write? Here I can write. The length of the lattice rectum is 2b square over a. Understood? No, just we can calculate the distance between the 2 points. Length of the lattice rectum is equals to 2b square divided by a. Next, we can get a circle here. That circle is called as auxiliary circle. We can call that circle as auxiliary circle. What do we call this? Auxiliary circle. So what is this auxiliary circle? What is the equation of this auxiliary circle? Equation of this auxiliary circle is x square plus y square equal to, see, this complete distance is required for us. This complete distance is nothing but radius, so that is a here. So x square plus y square is equals to a square. This is called as auxiliary. What do we call this? Auxiliary circle of the ellipse x square over a square plus y square over b square equal to 1. When a is greater than b, the equation of the auxiliary circle is x square plus y square is equals to a square. X square plus y square is equals to a square, right? And here you see, we measure these 2 points. These two ends are called as vertices. What we written here, vertex equals 0. This is not vertex, this is center. Center is 0 comma 0, and we can call these two ends. Suppose this is a, then this should be a prime. This a and a prime, these are called as vertices. What are the vertices here? What are the vertices? This is a comma 0, and this is negative a comma 0. So the vertices are a comma 0 and negative a comma 0. In case of parabola, we have only one vertex, but here we have two vertices separately, and the center is separate. Okay, center is separate, and we have two vertices. For circle only the center will be, and for parabola only vertex will be. But here for the ellipse, we have center as well as we have two vertices. Not only two vertices, two focus means two focus means foci. We have foci and two vertices and two directrix, right? Have written equation of directrix? Yeah, equation of directrix also we have written x is equals to a over e and x is equals to minus a over e, right? Yeah, tell me, students, do you have any doubt in this up to here? These points, these basic points are very important. That's why I'm spending much time on this. Instead of discussing the questions, I am focusing much of the time on this basics, because questions they are asking directly on the concept itself. Okay, right? Then you see here, this is for a greater than b. This is for a greater than b. What do we call this parabola? We can call this parabola as horizontal. What do we call this ellipse? We can call this ellipse as horizontal ellipse. What do we call this? Horizontal ellipse. Then what do we mean by vertical ellipse? Vertical ellipse means just you can rotate the figure like this. Just you can rotate the figure like this. How it could be? It will be like here. I can draw here x square by a square plus y square by b square is equals to 1. Here b is greater than a. B is greater than a. Then what do we call this ellipse? We can call this ellipse as vertical ellipse. We can call this ellipse as vertical ellipse. Now in this vertical ellipse, the major axis will become y axis. The figure will be like this. This y axis is called major axis. Y axis is called as major axis. And x axis is called as minor axis. Okay, already we have discussed, that's why I am writing directly. And then the ellipse will be like this. Okay, this is the ellipse. Here we have the center. What is the center here? Center is 0 0. There is no change. Okay, standard equation also same, sir. But how do we identify? We can identify with the help of a and b. If b is greater than a, then it is vertical ellipse. If a is greater than b, then it is horizontal ellipse. So the center is 0 comma 0. Now these two, what do we call this? Vertices. So what are the vertices here? The vertices are, this is 0 comma b and this is 0 comma negative b. 0 comma b and 0 comma negative b. These are the vertices here, 0 comma b and 0 comma negative b, right? And next, what are the equations of the directrix? And before that, first we can write focus. Here and here we can get focus now. This is focus. So foci means what? We can substitute y equal to 0, x equal to 0 here. If we write x equal to 0 in this, what is the value of y? What is the value of y, sir? If you write x is equals to 0, what is the value of y? So the foci b, 0 comma b, and this side what do we get? 0 comma okay now, sir, these are called the focus, 0 comma b and 0 comma minus b. Right. Next, the equation of directrix. Here one directrix we can get. Here also we can get one directrix. What is the equations of this directrix? This is y is equals to b over e, and this is y is equals to negative b over e. Y is equals to b over e and y is equals to negative b over e. Both the directrix also we have. Here we can write a directrix. What are the directrix? B over e, y is equals to plus or minus b over e. These are the equations of the directrix, right? Next, anything we are we missing anything? Are we missing anything? Means remaining things are always remaining all are same, no sir. Remaining all are same. That means what do we say? Lattice rectum. What is lattice rectum and what is double ordinate and what is length of the lattice rectum? There is no change in the length of the lattice rectum, but extremities of the lattice rectum can change. Extremities of the lattice rectum can change. Just we can here just we can do like we can convert what do I say? Uh, we can we can flip x as y and y as x. Then everything will come. So if you see the ends of the lattice rectum, what are the ends of the lattice rectum here? In the previous case, what are the ends of the lattice rectum? In the previous case, already we have discussed ends of the lattice rectum. No, what are the ends of the lattice rectum? AE comma b square over a. AE comma b square over a. So in the similar way, here also we can get that ends of the lattice rectum, right? What are the ends of the lattice rectum? May I know? Can anyone? What are the ends of the lattice rectum? Anyone, please? Ends of the lattice rectum. What are the ends of the lattice rectum in case of what is this? Vertical? Yes, in case of vertical ellipse. In case of vertical ellipse, what are the ends of the lattice rectum? We can do one thing. Let us go with the table. Let us draw a table. In that table, we can understand everything. Means what are the coordinates in horizontal ellipse? What do we get? And in vertical ellipse, what do we get? That all we can understand. So let us move to the right. See here. Standard equation, horizontal ellipse and vertical ellipse. So first let us take a standard equation. So in both the cases standard equations are same. So for a horizontal ellipse the standard equation is x square over a square plus y square over b square is equals to 1. Here also the standard equation is same, x square over a square plus y square over b square, which is equals to 1. But how do you identify whether it is horizontal ellipse or vertical ellipse? If a is greater than b, if a is greater than b, it is horizontal ellipse. If a is less than b, then that is vertical ellipse. Next, centers. What are the centers, sir? Centers are same. Centers are here. The center is 0 0. Here also the center is 0 0. Right? In both the cases the centers are same. Next, what is the length of the major axis? What is the length of the major axis? Here in case of horizontal ellipse, what is the major axis? The major axis is x-axis. The major axis is x-axis. So what could be the length of the major axis? It is a 2a. Length of the major axis is 2a. And in case of vertical ellipse, y-axis is the major axis. Then the length of major axis will be 2b. And obviously the length of the minor axis, this will be 2b and this will be 2a here. Okay. Next, vertices. What are the vertices here? The vertices are here plus or minus a comma 0. In one end we have plus a comma 0 and in the other end we have minus a comma 0, right? If you want to write separately, you can write it. And in case of vertical ellipse, what do we get? We can get a 0 comma plus or minus b. 0 comma plus or minus b, sir. 0 comma plus or minus b. Okay, no? And the next one is a foci. So what is the focus for this horizontal ellipse? For horizontal ellipse, we can get AE comma 0 and negative AE comma 0. Nothing but it is nothing but plus or minus AE comma 0. It is nothing but plus or minus AE comma 0. And in case of vertical ellipse, what could be the foci? In case of vertical ellipse, the foci could be 0 comma BE, or else we can write 0 comma plus or minus BE. 0 comma BE, or we can write it as 0 comma plus or minus BE. Okay, now next, equation of the directrix. Equation of the directrix. What is the equation of the directrix in case of horizontal ellipse? Already we have discussed. In case of horizontal ellipse, it could be like x is equals to a or e. Yes or no? X is equals to a or e, or x is equals to a or e one side and x is equals to minus a or e other side. So here directly we can write it as x is equals to plus or minus, okay, plus or minus a over e. X is equals to plus or minus a over e. Alright. Next, in case of vertical ellipse, the equation of the directrix is y is equals to, we can write y is equals to plus or minus p over e. Am I correct? Y is equals to plus or minus b over e. Okay. Then the next one. What is the next? And here you see, based upon these 2 points, based upon this foci and equation of the directrix, what is the distance between foci, sir? What is the distance between foci? Here one of the foci is AE comma 0 and the other foci is minus AE comma 0. Then what is the distance between these two? Distance between these two foci is 2AE. And here in case of vertical ellipse, the distance between foci is 2 times BE. And if we come to the equation of the directrix, equation of directrix is x is equals to plus a over e and x is equals to minus a over e. Then what is the distance between both the directrix? What is the distance between both the directrix? That is nothing but 2a over e. Distance between both the directrix is 2a over e in case of horizontal ellipse. And in case of vertical ellipse, the distance between two directrix is 2b over e. 2b over e. Okay, am I clear? And the next one is, yeah, we can move to the next page, right? Relation between A and B. Okay, most of the students can confuse here to write the relation between A and B. Okay, most of the students every time they can confuse regarding this relation between A and B. What is the relation between A and B, sir? In case of the first one, this is horizontal. Here it is horizontal and this is vertical. In case of horizontal ellipse, the relation between A and B can be written as, what do you write? B square is equals to A square times 1 minus E square. B square is equals to A square times 1 minus E square. Okay, so here what is the condition? A must be greater than B, and if A is less than B, then we can write here A square is equals to B square times 1 minus E square. Don't be confused, students. Remember this property correctly. If it is vertical ellipse, we can write A square is equals to B square of 1 minus E square. If it is a horizontal ellipse, we can write B square is equals to A square of 1 minus E square. Okay, how do we identify whether it is vertical or horizontal? If A is greater than B, it is a horizontal ellipse. If A is less than B, it is vertical ellipse. Next one is extremities of the lattice rectum. What are the extremities of the lattice rectum? The extremities of the lattice rectum are, for example, for horizontal ellipse, it is AE, yes or no? AE, comma, B square over A. This is the top one. The bottom one is minus. So AE, comma, plus or minus B square over A. AE comma plus or minus B square over A. These are the extremities of the lattice rectum in case of horizontal ellipse. Next, extremities of the lattice rectum for vertical ellipse. For vertical ellipse, what do we get? For vertical ellipse, we can get here plus or minus A square by B, plus or minus A square by B comma B. Am I correct? Plus or minus A square by B. Yes, plus or minus A square by B. Yeah, plus or minus A square by B come B. So what I'm thinking, better we can take plus or minus AE comma plus or minus B square by A also we can write, because total possibilities, total 4 possibilities. Here also we can get a total all the 4 possibilities. Plus or minus A square by B comma plus or minus BE, and next one is plus or minus AE comma plus or minus B square over AE. These are the extremities of the lattice rectum. Next one is what? Length of the lattice rectum. Yes, how do you get the length of the lattice rectum? Just you can calculate the distance between extremities of the lattice rectum. For example, in case of horizontal ellipse, what is the length, sir? In case of horizontal ellipse, the length is B square. B square over A plus B square over A. This is 2B square over A. In case of horizontal ellipse. And if it is vertical ellipse, we can write it as 2A square over B. 2A square over B. What is the next point? Parametric coordinates. So what are the parametric coordinates? Here the parametric coordinates are, see, here I can write x square over A square plus y square over B square, which is equals to 1. So if we replace x is equals to A cos theta whole square by A square, and y is equals to B sin theta whole square by B square, which is equals to 1. Can it satisfy A cos theta, B cos theta, B sin theta or not? We can check it. So A square gets cancelled. We are getting cos square theta plus sin square theta. And this cos square theta plus sin square theta is always 1. So here A cos theta comma A sin theta, B sin theta. A cos theta comma B sin theta represents parametric coordinates of horizontal, what do we call? Horizontal ellipse. For vertical ellipse also same, sir. For vertical ellipse also the parametric coordinates are A cos theta comma B sin theta. A cos theta comma B sin theta. Okay. And next one is what? Auxiliary circle. What do we mean by auxiliary circle? Here auxiliary circle is nothing but, in case of horizontal ellipse, we have x square plus y square is equals to A square. In case of vertical ellipse, that is x square plus y square is equals to what we have? B square. And then next one is PS plus P dash. This is also important point. So PS plus PS dash is nothing but 2A, sir. Okay, in case of horizontal it is 2A, and in case of vertical it is 2B. In case of vertical it is 2B. So PS plus PS dash is equals to 2A and 2B. Right? This is the basic information about the ellipse, standard equation of the ellipse, and the major differences between horizontal ellipse and vertical ellipse, and the things what we have learned till now. All the relations, like relation between A and B, lattice rectum, length of the lattice rectum, parametric coordinates, auxiliary circle, and PS plus PS dash. Again we can discuss about that PS plus PS dash. And before that we have discussed about the center, and then vertices, and then what we have discussed, this one, foci. Okay, equations of the directrix, distance between the directrix, distance between the foci, everything we have to remember. Okay, all right. Important methods and tricks. So here important methods and tricks. So the last point in the last page we have written what is the last point. PS plus PS prime is equals to 2A, no? That is the 2a in case of horizontal ellipse, and ps plus ps prime is equals to 2b in case of vertical ellipse. But generally, to calculate that, many of the students can use distance, many of the people can use distance formula, but distance formula we cannot use here. If you use distance formula, the calculations will become very lengthy. So instead of using distance formula, we can go with another method that we can discuss now. Okay, that is one of the major trick here. And all important methods, yeah, while doing the questions, while doing previous year PYQs, we can discuss all the methods whatever required to us. Okay students, and again here about the Spark Academy, this is what is there on the screen, that is a Spark Academy store. Okay, what are available in the Spark Academy store? Long-term courses are available, and crash courses are available. Next, mock test, and then they can, yeah, there we can get previous year solutions, full length test, study materials. And Spark Academy can give exclusive training for JEE Mains and NEET, EAMCET, IIT Foundations, highlights and more. And here about this crash courses, I can tell you one point. They're going to start the crash course, they're going to start the crash course from, what do I say, they're going to start the crash courses from April 18th. One of the batches going from April 18th, and the other batch is going to start from May 20th. So try to remember these points. And here I forgot to add the one more slide. In that slide, they mentioned the code to the particular, they have mentioned the code. If you use that code to join the course, then you can get a discount. I think 10% of the discount, I think 10% discount maybe. So you can get the discount. In the next class, I can try to provide the code what they have given to me. I can show it on the screen. Try to make a note of that code, and you can, if you want to join in the institute, then you can join with the help of that code. Then you can get 10% discount on the fee, right? This is about the Spark. And the next one is, yeah, short term. This is about like it is looking like admission slides. What is there on the screen, that is a classroom, offline classroom atmosphere. And here they can give long term and short term. The timings for long term and short term coaching is 10 a.m. to 4 p.m. and for regular coaching it is 6 p.m. to 9 p.m. and they have the branches in Naranguda and Mehdipatnam. 2 branches we have. Yeah, already I have told you know about online courses, right? What do we call this? Live sessions. Next one is common live sessions. Common live sessions means offline as well as online at a time, both can run set. Those are unable to attend the offline classes, they can attend online classes also, right? Next, yeah, our methodology. The methodology of this Spark Academy is, first we can start with basic concepts. Once the basic concepts are completed, then we can give you the shortcuts, how to solve the questions in shortcuts. And once the shortcuts is given, then we can go through all kinds of questions, all the model questions we can discuss. Then we can go through the exercise questions. If once we complete this first 4 things, then we can discuss the PYQs. Okay, then we can ready to take the test, chapter-wise test, weekend test, grand test, and test analysis, right? These 4 points are main points. Basic, teaching basic concepts, then shortcuts, then all model questions, then exercise questions. In the classroom we can give you the basic concepts, and then we can go through some examples. After giving basic concepts with examples, then we can give you the shortcuts, again shortcuts with examples. After giving shortcuts and examples, then we can go through all model questions. Means in the classroom itself we can discuss all model questions, then the exercise questions. So we can give these exercise questions to the students itself. They have to solve these questions based on above 3 concepts, because in the above basic concepts and shortcut methods in all model questions, already we have discussed many of the examples. That is the reason we are giving these exercise questions to the students to solve them. So once they solve that questions, If they have any doubts or any queries in that questions, they can we can discuss in the next class itself. That is the in that way we can complete the portion here. This is the major part, right? And then PYQs at the end of the topic we can discuss PYQs also. After that, every week we have weekend test, and this is chapter after the completion of every chapter you can take chapter test also. And yeah, grand test also we can conduct, and test analysis will be given to you, right? Right. The next point, what is the next point here? Let us see, let us take one example, any one example first. Okay, the example is like x square over 16 plus y square over 12 is equals to 1. X square over 16 plus y square over 12 is equals to 1, right? Now we have discussed many points, right, in the previous slides. Let us see how that all will work out with this question. X square over 16 plus y square over 12 is equals to 1. So first let us find the value of a. What is the value of a here? The value of a is under root of 16, that is 4, and the value of b, that is under root of 12. So what it is under root of 12? Under root of 12 is nothing but 2 times the square root of 3. Then what is the relation between 4 and 2 times square root of 3? What is the relation between 2 and square root of, sorry, 4 and square root of square root of 12, sir? So here clearly a is greater than b. Then what kind of ellipse it is? It is vertical ellipse, right? It is vertical ellipse. And then what is the center for this vertical ellipse? Whatever it is, vertical or horizontal, the center is 0, 0. And then next we are going to write the vertices, right? What are the vertices? What are the vertices? Here, as it is vertical ellipse, what are the vertices, sir? Plus or minus a, 0. So that is plus or minus 4, 0, right? Next, after the completion of vertices, then we can write what is the distance, okay, length of the major axis also we can write here. What is the length of the major axis? Length of the major axis is 8. Then immediately we can write length of minor axis. What is length of minor axis? Length of minor axis is 4 times square root of 3. So center, vertices, length of major axis, length of minor axis. And then we can also discuss here vertices. Already we have discussed vertices. Then let us come to the foci. What is foci are here? Plus or minus AE, 0. Yes or no? Plus or minus AE, 0. But here we have A value, but we didn't calculate E value here. First let us try to calculate what is E. Already in the above tables we have discussed the relation between A and B. What is the relation between A and B here? If it is vertical ellipse, then we can get B square is equals to, if it is vertical ellipse, then we can get B square is equals to A square times 1 minus E square. Yes or no? So here B square, what is B square? B square is 12. And what is A square? A square is 4. 1 minus E square. So what it is, 3 is equals to 1 minus E square. Yes or no? 1 minus E square. Then what is the value of what is the value of E, sir, here? What is the value of eccentricity? Are we writing correctly? What is the value of eccentricity? What is A square? A square is 16, huh? Written only 4 here. A square is equals to 16. So here 4 3s, 4 4s, then this is 3 over 4. So E square is equals to 1 minus 3 over 4. 4 minus 3, this is 1 over 4. So E is equals to 1 by 2. Am I correct? E is equals to 1 by 2. So eccentricity is equals to 1 by 2. Then foci is equals to plus or minus AE, 0, right? So plus or minus AE, 0 means plus or minus, what is A, sir? A is 4. 4 times 1 by 2. Correct or no? 4 times 1 over 2. What is 4 times 1 over 2? 2, 0. Okay, 2 comma 0. Am I reading correctly or any mistakes? 2 comma 0. Right, sir. Okay. Next, after foci, what we have? Length of minor, length of major also completed. Equation of directrix. What is the equation of? Let us make it fast. Equation of directrix. What is the equation of directrix? As it is vertical ellipse, we have x is equals to a over e, right? Plus or minus a over e. So what is a value here? A value is 4 plus or minus 4 divided by 1 by 2. So this is plus or minus 8, right? Equation of the directrix also completed. Next, equation of the directrix also completed. Oh, okay. uh, Mainly here we know the value of a, the value of b, and the value of e, sir. So we can calculate the remaining all parts with the help of the above table, because already its time is completed. In the next class we can discuss the questions, right? We can do like ellipse 2. In that class we can discuss some previous year questions, right? Thank you, students. Thank you, everyone.